Okay. Okay, so that is recording. So we have just literally done the starter questions. So for each of these now, I'll just go through the answers. Okay, so this first question, both linked to percentages. I realise that they're both percentage decrease questions actually, which I didn't intend when I planned it. I meant to do an increase and a decrease, but so we've got quite a lot of people who've got that right. So James, Karen, Nicole, Stephen, Grace, Jack, Darcy and Kate have all got that right. And then we've got quite a few people who are nearly there. So let's just have a little quick look. It's a decrease. So firstly, that means that the answer is going to get smaller. Yeah, so you need to remember the increase and decrease. An increase, it goes up, and for the decrease, it gets smaller. Now you have got percentage increase and decrease coming up on this paper, this next paper. So first of all, we want to work out what 26% of 3,600. Now, can you tell me in the chat, what does of mean? If you see the word of, what can you put in your calculator in place of an of? Because we have to remember that we have got calculators for these questions. Yes, well done, Kate. Times. So, and Bradley, good. So of means times. So you can literally type in 26, the percent button, times by 3,600, and we get an answer of, is it 936? I can't, I've got the final answer. I didn't get the first answer. Let's just quickly work that out.
Yeah, that's what I got, Vicky. Yeah.
Yeah, thanks, James. Yeah, 936. I've wrote the final answer down, but I didn't do the little working out in the middle. Right, so 936. So some people did put 936 down as their answer, so that's really good. However, you need to remember it's a decrease, so that would get you 1 mark. And then you need to remember it's a decrease, so we need to take that away. So we want to then get our 3,600 and take away your 936, which gives you 2,664. And obviously you do all that on your calculator. We don't want to see any column methods or grid methods for the calc paper. Okay, so yes, well done, Nicole. So this one is also a decrease. It's a little bit worded. You've got a £600 telly and it's being reduced by 18%. So again, we want 18% of 600. Of means times, so you're going to put 18% of 600, which I don't know what that was.
108.
Thank you. 108. So I think some people again did give 108. So like I said before, that is 1 mark. And I did give some people feedback just to remind you, don't forget to take that off. 600 take away 108 gives us a final TV cost of 492. Okay, good, well done. So percentage increase and decrease. So obviously we're taking it away. If it was an increase, you'd add it on. Okay, so next, now bid mass. So we need to remember any sum that you see that has more than one operation in it, so more than a times or more than just an add, that you need to apply bid mass. You need to think about the order in which you do each operation. So firstly, for this, there's no brackets, there's no indices. There is a divide and a multiply. So I'm just going to explain again, because my classes probably all know this now, but divide and multiply are equal. They go together. They're like a little married couple and they do everything first, okay, but they are equal. Add and subtract. Now, add and subtract are also equal. Divide and multiply comes before add and subtract. So we've got multiply here. 4 times 8 is 32. 5 plus 32 is 37. Thought I'd got that wrong then for a minute. Okay, good. So lots of people got 37 for that one. Now this one is a bit more tricky because it ends up, we do the divide and multiply first, which is 6 here. And then you've got 10 take away 6 plus 5. Now we're left with a sum that has an add and a subtract in it. So it's got more than one operation, so we need to apply BIDMAS. However, add and subtract are equal. One is not more important than the other. Divide and multiply is more important than add and subtract, but within add and subtract, they're both the same. So you don't do 6 plus 5 and then take away 10. We do it in that order. 10, take away 6, which is 4. My brain's gone. Plus 5 is 9. So the final answer for that one was actually 9. So I think there's quite a variety of answers. I mean, so many of you got that right. I don't want to actually read them all out, but lots of people got that one right. And I did give feedback to a few people, and it looks like people have changed their answers. So that's really good because it means that you've been able to process it. Good. Well done. James. The number machines, yeah, really. Well, no, with number machines, you need to go in the order through the function machine. So across, the only thing with the number machines is if you go back the other way, you do it in reverse. So if it's a times that way, when you're going back, you divide it. So number machines, you have to do it in the order that comes up, actually. Lots of messages there. Okay, good. So next, which of the following numbers is not a prime? So we want not a prime. Now, a prime number is a number that's not in anybody else's times table. It doesn't appear in any times tables. So we have to go through our times tables and think, does 11 appear in any times table? Does 11 have any factors? It's only got 1 and 11. It doesn't appear in any times tables. It's got 2 factors, so 11 is prime. 15, if we do the factors of 15, it appears in the 5 times tables because you've got 3 times 5, so it's in the 5s and the 3s. That means that 15 is not prime, okay? And then if we look at the others, 17, that's only got 2 factors, 1 times 17. It doesn't appear in any other times table, therefore it's not prime. Sorry, it is prime, God. And then 19, again, 19, if we think of all the factors of 19, it's not in any other times table, so it doesn't have any other factors other than itself and 1, which means that 15 is the answer for this one. And if we were given a reason, it's because it appears in the 5 times tables and it appears in the 3 times tables. So that means it's not prime. OK. This one caused a bit of confusion, I think. So state whether the following statements are true. So this thing is an inequality, and what it means is the thing on this side is bigger than the thing on this side. So if I put an 8 is greater than a 6, that would be classed as true. If I put it going the other way, that means that the thing on this side is small. The thing on the small side, so maybe a 5, is smaller than the thing on this side, so maybe a 7. That would be true. So you have to state which of these is true. So 0.65, it says, is bigger than 0.7. So that's actually not true, because if we make them both 2 decimal places, that would be 0.70. And 0.65 is obviously smaller, so it should actually look like this. So that one's not true. This one, 0.1, is bigger. So I think Bradley put this one into the chat. 0.1 is bigger than 0.05 because, again, if we did it to 2 decimal places, that becomes 10, and that one is 5. So that one is true. And then 0.7, if you put that into a decimal, 7 divided by 10, or if you use your fraction button and put a 7 over 10 and turn it into a decimal, it's 0.7. It's the same as 0.7. So actually, this isn't true because it says that 0.7 is greater than or equal to 7/10. Actually, 0.7 is equal to 7/10. So that should look like that. OK, so it's just looking at the symbols and making sure the thing on the small side is the smaller number and the thing on the big side is the bigger number. OK. Expanding brackets. So if lots of people got these right, I don't want to necessarily go through them. And I think I've seen pretty much everybody got those right. So that's really good. So very, very quickly, 4x times 2 is 8x squared. 4, so you've got your x's times your x, don't forget your squared. 4 times 3 is 12. So I think everybody got that one pretty much. There's some variations of it, but you're all not far off. Now the double brackets is a little bit tricky. We haven't really done this. So you can just do it like a grid. You can just say that that is times by that. So if we did 4x and then plus 5 here, and then we did 2x plus 6. Times. So 2x times 4x, 2 times 4 is 8x squared. You've got 2x times 5 is 10x. You've got 6 times 4 is 24x. Wow. And then you've got 6 times 5 is 30. And then we just need to write that out and we need to sort of simplify it a little bit. So you've got, oops. Now, we haven't done a lot of double brackets in class, but I just wanted to put this in as a little extra just in case there was anybody stretching for a 5 who wanted to try the harder stuff. So we've got 8x squared. Now, your 10x and your 24x, they're both positive, so that's 24x plus 10x is 34x. So we've got 34x's in total with that one and that one. They simplify together to make 34x, and then we've got plus 30 there. So that is actually quite tricky. So we've got an 8x squared in there, so that's really good. Well done, Harry. You were really close. You'd get a mark for that. You'd get a mark for the 8x squared. Aaliyah, yes, Aaliyah's got it. Is it Aaliyah or Aaliyah? Sorry if I'm pronouncing that incorrectly. Darcy smashed it. Well done. Kate, you've smashed that one as well. Brilliant. That's really, really impressive. So that's good. Don't worry if you haven't been able to do that, but it's just basically that times by that. They're next to each other. There's no gap in between. So it means that they're times, and you just times it like you would like a normal multiplication grid. Oh, that's good. I'll try to not get that. Yeah, James, that's a good one. It's a good method. Good. So if anyone wants any more of those in a bit, I can always put some up and you could practice them. But well done. There's lots of people got that right. So that's really good. Right, what is the value? Now, this decimal place value is something that's coming up on the exam. It said it's coming up on the advanced information, and we're a bit like, what even does that mean? So this is my interpretation of what they would expect you to know for decimal place value. That actually with your decimals, so we all know hundreds, tens and units, don't we? So if it was like a number like 327, that's hundreds, tens and units. That's your place value for each of those. 300s, 2 tens, 7 units. After the decimal, you have tenths and hundredths. I'm just going to do it like that. So any numbers that come after this, so if we had like we've got a 0 and a 6 after it, 0 and a 6, the 6 is in the hundredths column. So therefore we have 6 hundredths, which is that one. OK, so most people, I know lots of people did put 600, so that's really good. Nobody put 6 tenths, which I'm pleased about. If there was a number that was like 327.42 and it wanted to know the value of the 4, that's in the tenths column. So it's 4 tenths or 0.4 is the same. This is 6 hundredths. 60 is tens and units, so that's in the tens column, so that's like 6 tens, which is worth 60. 6 tenths would be 0.6, not 0.06, and 6 is obviously 6 units, so that's like 6 whole ones. So the decimals, that's when they become fractions. So the number straight after the decimal is tenths and then hundredths. Hopefully that makes sense. Right, okay. So that's the starters taken quite a while. What are we on? To keep an eye on the time. But I think all those questions are really valid because they're all coming up in the, all those topics should be coming up in the exam. So, right, the topics that I've chosen to go through in this session today. This morning, I think we selected some that we thought would be useful. And then this afternoon, I've picked some which I think would be useful. So we've got reading and interpreting pie charts because we don't really do much of that in lessons. We haven't done much of that this year. We've got calculating mean and range, which probably lots of you are like, oh my gosh, we can do that. But there are some questions I've thrown in, some different ones. Hopefully you'll whiz through the mean and range questions easily. And then we've got a bit of Pythagoras' theorem in there as well. So what I'm going to ask you to do as well, while we're going through those, is we've got loads of time, really, so we should easily get through all of those topics. It's about half an hour for each one, I'm thinking. But if you would prefer me to go through something more than others, then maybe put some messages in the chat. And if I get an overwhelming, I'm going to do reading and interpreting pie charts first. If lots of people would rather Pythag next, let me know in the chat and I'll go over Pythagoras' theorem next. So hello, Bradley, welcome back. And James is terrible with graphs and equations. Did you do that this morning? Did you do the session this morning, James? Because I think Polly did the M and the X this morning with Y equals MX plus C. Polly did do that this morning, and you did you do that this morning?
No, I couldn't make it. Sorry, Vicky. So I mean,
that's all right. So what I'd say is that's been recorded. That's been recorded, and it's being turned into a YouTube video, so it's easy to watch. So I would watch that one back for that.
Brilliant, thanks.
Okay, cool. All right then. So let's do pie charts to start with, and then we'll look at if people would rather have Pythag rather than mean and range. Let me know in the chat which you'd want me to do next. Okay, so firstly in the chat, I want you to give me a quick vote. I want to know which town you think the most people travel to work by bike. So is it, and you probably can't see it, the bike is the red lines. So is it the one on the left? Let's call this town A, and this is town B. Quick one in the chat, which one travel to more people travel to work by bike? Yes, A, the left, one on the left, yeah. This is quite good. I can see that it says people are typing, which we don't get normally in the online lessons, do we? And I'm like, is anyone responding? And I can actually see it says everyone's typing. So good. Everyone said the one on the left, obviously, right? That is obviously more because the portion of the pie chart is actually bigger. So it's obviously more. Now it says the population of this one is 2,000 and the population of this one is 10,000. So which one do you still think the one that travels, which one now travels the more by bike? Has your answer changed? That's the question now. So do you still think it's town A? Luke thinks it's changed to town B. Yeah, it has. It's now the right. Okay, because how many that pie chart is out of is obviously really, really important. So here, this is just 2,000, which means half of the pie chart there is going to be worth 1,000. This pie chart is earlier, we were like, well, yeah, obviously it's a smaller portion, but how could we possibly say when we didn't know how many the pie chart was out of? The pie chart is out of 10,000 people. That means that is, well, just short of 5,000, maybe like 4,000 people. I'm going to go like 4,500 and completely guessing and completely making that up because I don't have an angle size. If I knew how big the angle was, we would be able to work out exactly how many people travel to work by bike for this one. Okay, so here we know it's half because it's clear fraction. This one is harder to tell because there's no angle size. And these are the two bits of information that you need to be looking at when you're interpreting the pie charts. Okay, so Here, the pie chart shows colours of sweets in a bag. What is the most common colour? Now, you don't need to necessarily put that into the chat because it's fairly obvious. Green is clearly more common because that's the bigger portion. OK, the least common colour of sweets is red. Now, what fraction of the sweets are white? So it's got a little angle there. So if you could, can anyone tell me what is the fraction of the sweets are white as a fraction? Bradley's saying a third. Luke's going a quarter. Harry's saying a quarter. Yeah, so a couple of people have given me 90, which is interesting because it's 90 degrees. It is 90 degrees, you're not wrong. It's 90 degrees out of, how many degrees is it out of in total? Does anyone know what the complete circle is out of? It is, thank you, Ty, it's 360. So it's 90 degrees out of 360 degrees, which if we used our fraction button, I don't need to use my calculator for that. I know that it is a quarter because actually, if we were to have a pizza and we split it into 4 like that, they're quarters, aren't they? And that is 90 degrees, the same as that. So a 90-degree angle, there's 4 90s in 360, so that is a quarter, and that one's quite easy to do. We know that it's a quarter. If it was like halfway through, if that was green, then that would be a half, wouldn't it? And then you need to use the actual angle size to calculate how many red and what portion that would be, that's what we're going to look at next. So here, the most popular language, why a pizza? Sorry, Luke, I don't know. It's just a round thing, cake, maybe. It's always food, isn't it? Why is the most popular language? So you don't need to tell me that. We can see that the most common one, I know that you all know that, it is French, and that is a half of a portion. So it's quite easy. I'm not asking you questions that are too easy. What fraction of the students studied French? We can clearly see that is a half, isn't it? So if there are 300 students who attend the school, how many study French? Well, it's a half of 300, which I don't want to insult some of you because I know that you mostly all know that that is going to be 150 students. Yeah, it's just a half of the total amount, which is 300. That's super easy. It's building you up a little bit. Now here it tells us we haven't got any nice easy fractions. Now these are the ones that get a little bit tricky. Even this one is less than 90. It looks like 90, but it's not, it's only 80. So how many students said, so 90 students were asked if they wanted to attend a history trip. So how many students said no? So what we need to do here is to work out what 40 degrees is as a fraction. Now what I just did earlier, we did 90 degrees as a fraction. 40 doesn't fit quite as nicely. It's 40 degrees, like you told me before, out of 360 degrees in total. Okay, so you can do this on your calculator. You can either do it as a fraction button. If any of you have got access to a scientific calculator, you can do 40 like this in the fraction button. If you haven't got your scientific calculator, don't worry because you can just literally do a divide. So 40, remember that this line is divide. So we can do 40 divided by 360. Gives us how many as a decimal probably, that's the problem, divided by 360 is 0.111, which is like a really tricky answer. Harry's got, some people obviously got scientific calculators. Mine is well dodgy, my calculator I'm using today. 40 divided by 360. Now all we need to do is times that by how many students we've got in total. So I'm going to times that by 90 students in total. And that gives me 10 students. Okay, yeah, so it was 0.1. Yeah, Karen, I got 0.11111 as well. So did Bradley. And then I'm like, oh, that's tricky. But if you literally times that by 90, then you get how many students. And I've times it by 90 because that's how many students there were in total. Okay, so what fractions of the students said yes? So again, you can just do that. I mean, as a fraction, 240 over 360. and then simplify it, or just press equals on your fraction button and that will simplify down to a third. There's, no it won't, it's 2/3, my bad, hang on. Definitely bigger than a third, isn't it? This, it's 2/3. Thank you, Nicole. You guys are well on it, aren't you? So that is the 240 degrees there. It's out of 360 in total. If I wanted to know how many students that were, how many students said yes, which is the next question, you can literally just do 240 over 360 times by how many students they asked in total, which is 90. Or 2/3 of 90 if you've managed to work it out as a fraction. Okay, how are people feeling with that so far? If you think that that's not too bad, or how are we okay with those? Give me a thumbs up or a smiley face if you like. I'm okay, we get it, we want to have a practice at some. What about those tricky numbers that are a bit more difficult, like 40 degrees and 80 degrees? Yeah, a few smiley faces. Okay. Okay, good. So generally lots of people are okay with that. So I'm going to let you go on to Desmos. I'll open up the next slides. Now, because these have got pictures, I have to do this over the space of 3 or 4 slides. So I think we've got 1, 2, 3. 3 slides on Desmos now for you to have a little go at. So fab. You guys race. I wish I had online lessons like this all the time. Normally it's just like me and James and Harry all on our own, isn't it, guys? You two just the only ones ever answering any questions. Okay, cool. Right, so I'm going to...
I was just laughing at that, Vicky, that's funny.
There's actually people responding, it's quite nice. I don't feel like I'm talking to myself. Right, okay.
Like wicker baskets or like little rolling things rolling past or anything like that.
I don't know, tumbleweeds.
Yeah, that's it.
Okay, right, I'll give you a few minutes piece to answer some of those questions on Desmos, okay? And then we'll go through them.
Wait, where's the link, miss?
Sorry, it's just the same, back to the same Desmos that you're using for the starter. Do you want me to put the link in again?
Yeah, please.
Back onto the same Desmos for the starter, and then it's I've moved it on now so you can go on to the next few slides. Luke, I've just seen your question. Are you asking, is it slide 3 or, because I think there's like 3 questions on each slide, isn't there?
Yeah, it's just slide. It's just the first slide of paper.
The first slide. So how many students liked basketball? So it's 60 degrees. So you need to do 60 out of 360 or 60 divided by 360 and then times it by how many students in total, which is 80.
Okay,
Does that make sense?
it does now.
Thank you. Good, good. Okay, so I haven't give lots of feedback on those. Most people have got them right. The odd one or two notes that I've made to people. I did just have a delivery actually, so. Right, just catching up on where everyone's up to. I think most people have finished those. There is a couple that are still not finished, but don't worry because they're all pretty much the same. It's just practicing the same. We've not really done this in class. We've not really done much on pie charts at all. And although it's very difficult to do drawing pie charts online, it's almost impossible. I think that is something that it might be worthwhile with your teachers if you're not sure about how to find the angle and to actually draw a pie chart. That's something that you could practice next week. Well, no, it's the exam on Tuesday, isn't it? So it might be worth just sort of YouTube Googling, you know, how to actually draw a pie chart, because that's something that we can't really do online. But we don't know how the question's going to come up, and it might be an extract information question or a question just like this. So hopefully this will get you some marks, and it's familiarising you a little bit with pie charts. So if you do have to draw an angle, if you know that, you know, a third of the people wanted whatever, you'd be able to, you know, maybe now you'd maybe be able to work out that that would be like 120 degrees or something. So but that is something that might come up. So let's have a quick look at the answers. Okay. 80 students were asked what's their favourite sport. So I keep saying, how many times am I going to say so in the one sentence? Lots of people got this right. So what fraction likes sports? In fact, everyone pretty much got that. Just take care, Brad, you've given me how many students and you've accurately worked out how many students, but just be careful when you're reading the question. It is 40 because it's half. It is half. The fraction's half. So you've kind of done one more than you needed to. Just make sure that you answer the question carefully. But you obviously knew that that's a half, so that's good. What fraction of the students liked basketball? This is a bit more difficult. We had 60, so it's 60 degrees out of 360 degrees, which we can then turn into a fraction. And it is 60 divided by 360 is actually 1/6. 6 60s in 36, so it is 1/6. So I think lots of you got that. And then how many students like basketball? So it's 60 out of 360, which is a sixth, times by how many students in total? So times by 80, which is a sixth of 80, which is, I'm going to have to look at the answers because I don't actually know. I'm going with 13. I'm going to have to work it out. There's so many different answers. 60 divided by 360 times by 80. Yeah, oh, it's a bit dodgy that, isn't it? It's 13.3, which doesn't actually make any sense. But do you know why it doesn't make sense? Because I made the 80 up. So 13.3 students. So
I seen 13.33 and I thought, oh, do you know what? I'll just put 13.
13, yeah. I think you wouldn't get a question in an exam that gives you a point of the students. I didn't think that through, did I? Probably because I found the pie chart, just made the questions up myself, and that doesn't really fit very well, does it? But 13.3, yes, so you can have that. If you put 13 or 13.3 or 13.33, that's fine. You wouldn't get that in the exam. It would fit. Obviously, if it's people, it would fit nicely. So for this one, question 2, we've got what fraction of the students took the bus. So obviously that's good that everyone's got that one. Every single one of you got that. Well done. A quarter. What fraction of the students walked? So we've got 120 out of 360, which simplifies down to a third, which most of you got that. Brad, you've done 120 divided by 360, which is fine because that's actually what that is. So if you'd done that on a scientific calculator in your exam, you would have got the answer as a third on your scientific calculator. So that's absolutely fine. 1/3, how many students walked? So it's a third of the 36 original students. So like I said, 120 divided by 360 or a third times by the total number students is 12 students. And that one fits much better, doesn't it? So lots of you got that. James, Harry, Grace, Darcy and Karen got that one, and Kate. Okay, and then I think some of these people not everyone might have finished these ones. So 24 students, that's what colour eyes they have. The fraction of the students have green eyes, so it's basically the same question. It's a quarter. How many students have blue eyes? So we've worked out for this, it doesn't ask you what it is as a fraction. You have to do the fraction yourself first. So it's 120 out of 360 and then times by 24, which is 8 students. Which loads of you got that one. And then the last one, how many students have brown eyes? So for this, we don't have an angle, so it's a little bit tricky, other than we know that there's 8 have blue eyes, a quarter of the students have green eyes, which is a quarter of 24 is 6. So then you can work it out. You've got 6 there, you've got 8 there, so then that is 14, so there is 10 left over. So it's making a little bit of inference from that and having to sort of figure it out yourselves, but you've loads of you've done that, so brilliant, well done. Okay, right, that is pie charts. So we've got mean and range problems and we've got Pythag left to do. Oh, I've not been looking at the chat. We've got lots of questions. Okay, Jack, sorry, I didn't see that. Don't worry about it. Lots of people just saying that they've finished, so that's fine. Really, this is all for you. This is not a lesson that I'm logging your attendance. I mean, we will inform people and sort of, you know, give you a well done, but this is your own learning. So if you're doing your notes on paper, then that's absolutely fine. And if that's how you prefer to work, or that's how your only way that you can work because you don't have you can't work Desmos or whatever, that's absolutely fine. It's your learning, it's for you to learn from. It's not, we're not sort of gonna, you know, you're not getting told off for not doing it in a certain way or anything. So so we've got a bit of a we've got some people saying Pythag and some people saying mean. It's not mode anyway, it's just mean and range. So it's kind of a bit of a mixed bag. People want both, so we'll just make sure that we cover both before the end anyway. So I think Pythag's the harder one. So after 2 hours, you'll be tired out and you'll struggle with Pythag a little bit. So I'm going to go Pythag because I think mean and range, people can figure that out if they have to. Whereas Pythag is no. So Nicole, I'm sorry, we're going to go Pythag next and then we'll come back to mean and range at the end. Okay, so we definitely will do it, so don't stress. Skip past the questions and let's go to Pythag. Right, so Pythagoras' theorem. What is Pythagoras' theorem? So you won't actually get told in the question. Well, sometimes they do say use Pythagoras' theorem to calculate the length of the missing side or something like that, but it's not very often. So what you need to know is that Pythagoras' theorem is used to calculate the length of a missing side of a right-angled triangle. It's quite a big sentence. So if we get given 2 sides, animated this side. So if we got given 2 sides, say we got given A, which was 4 centimeters, and we got given B, which is like 5 centimeters, and the question says, what is the length of x? This is what you'd use Pythag for, because we use it to calculate the missing side, which is this, the length of a missing side of a right angle triangle, which is this. Okay, so the formula for Pythag, before I show it to you, so, well, does anyone know it? To be fair, you don't need to know it because it comes up on the formula sheet. So you don't need to learn it, which is good. They're going to give it to you. Let's move this out of the way. Oh, Nicole's on it. A squared plus b squared equals c squared. Yes, well done. So let's have a look. A squared plus b squared equals c squared. So write it down. You don't have to memorize it because it will come up on the formula sheet. What you do need to know is if you get a Pythag question, you need to turn to your formula sheet and you need to get the formula. Okay, so you need to remember Pythag comes up on your formula sheet. Anything to do with triangles, have a quick look at your formula sheet because you've got an area of a triangle on there as well. And there's other stuff on there as well. Trig, don't worry about that too much. Have a look at the Pythagoras theorem. Yes.
I've had a quick look through them papers. There's a couple of where they're not looking for the c squared, they're looking for, like, you know, the a squared, the side A or side B, rather than the hypotenuse.
That's fine. We'll do both today. We'll look at both.
Sorry.
That's all right. That's fine. No, it's true. Sometimes they'll want to know C. They'll want to know the longest side, and sometimes they'll want to know one of the shorter sides. All we have to do is jiggle the formula around a little bit. So if you remember a squared plus b, well, I've just said you don't need to remember. You don't need to remember it, but that's kind of the formula, but we just have to rearrange it a little bit for doing a shorter side. So the thing that's on here now, it's telling you that C, the thing that you do need to know, I'm going to highlight this, is that C is always the hypotenuse. And well done, James, I was liking your big words there, the hypotenuse. C is always the hypotenuse. So that is the side that is across from the right angle. So the side that's across from the right angle is always C. And then the other two are the shorter sides. So A and B are both shorter sides. So the thing to remember is that the hypotenuse is the longest side of the right angle. And A and B are always next to the right angle. Whoops. So the hypotenuse is directly across from it, and A and B are next to it. Change my pen to red. So that's what you need to remember. Tell you what, I'll put that into the chat in a minute, and then you've got a little bit of notes. So let's have a go at practicing and doing some. So calculate the longest side. So I'm gonna write it down. A squared plus b squared equals c squared. We want to know this one. What is x? So we need to know what is c. So this is c. This can be A. It doesn't matter which is which when it comes to B and A. You can have them either way round. A and B. Now A squared. So A is 3. So 3 squared plus B is 4. So 4 squared equals C squared, and we don't know what that is yet. 3 squared is 9. Remember, it's not 3 times 2. 4 squared is 16. Oh, let me get rid of that. And that is equal to C. So 9 plus 16 is 25, and that is equal to C. Now, we want to get C back to a squared number again. So C is 25. What do I do at the end when I want to know how long because C is not, the length of X is not 25 centimetres. What do we do at the end to find out what C, actually the length of C is? Because remember, it's C squared we want, so we want to get C back to a square number. Well done, Harry. Yeah, and Karen and James, you square root it. So at the end, square root of 25 is equal to 5 centimetres. Boom. Yeah, nice. So substitute in the numbers. square them both, add them, and then square root it. Let's do one more. So a squared plus b squared equals c squared. C is the missing side, across from the hypotenuse. So that's C. A and B are next to the right angle. It doesn't matter which order. So A is 6 in my example. B is 10 equal to C. 6 squared, 6 times 6 is 36. 10 squared is 100. Now, you need to remember that this is coming up on a calc paper. I've made this with quite nice numbers. So just remember that you'll probably get tricky numbers and you might have to square like decimals or something, but it's the number times by itself. So 6 times 6, 10 times 10, that might be like 7.2. You'd have to do 7.2 times 7.2. Whatever the question is, you just times it by itself. Then we've got 136. Remembering that 136 is C. So to get it back to squared number, we have to square root it. Square root 136. I've got this worst calculator ever. I left my working from home this afternoon. I left my scientific calculator at work. 11.66. Yes, well done, Ty. 11.66 centimetres. And Luke and Harry, well done, guys. And Nicole, you're all way quicker than me. Okay. So have a go at some of them. Don't panic, James. We'll go on to short sides in a minute. Have a go at those first. Now, just remember on Desmos, we've skipped ahead to Pythag, didn't we? So I'm going to just edit the pace in and I'm going to paste you to the Pythag questions, which are right over there. So we want slide 7. So I'll paste you to slide 7 and there's an exam question as well there. So you should be on slide 7 and 8. So if you go back to the original Desmos link, so if there's anybody, I'll put it in again. This is the notes from before. Stick that in. And then if anybody needs the Desmos link, it's way up here, isn't it? Put that back in case anyone needs it. Okay, so have a go at those questions. I'll give you a few minutes and we'll go on to the next ones. Okay, I can see that lots of people are saying that they're done, which is fab. So I'm not going to go through the answers yet because some people are not done. So I don't want to like give it away. But what we'll do is I'll just if you just sort of stop what you're doing for a minute, we'll go through the next bit and then you can finish off in a minute. OK, so then people can carry on then. And then I'll just give you the answers quickly afterwards because I'm thinking everyone's got the hang of that quite well. So the next bit is where let's go through them answers in a minute. Right, so the next bit is where we need to calculate a shorter side. So some questions, quite rightly, as James said earlier, they ask you not to do a long side, not the hypotenuse. They want one of the other sides. So this is fine. It's literally, we use the same. So again, calculate the side and the missing side of a right angle triangle. So we've got a right angle triangle. It wants to know what the length of x is. So we're going to use Pythagoras' theorem. So same formula, a squared plus b squared equals c squared. That's the formula always. And that's what will be on your formula sheet. So we need to label up our triangle. So that's c. So our c squared is actually 5 now. A and B are here. So A is 4 squared. And then B is what we're trying to find out. OK, so now substitute in. So 4 squared is 16. Just 1 second. What do you want? No, I'm on a lesson and it's being recorded. So go away, please. My little boy is on his school holidays, hanging around me, putting me off. Right, so 4 times by 4 is 16, plus something is 5 squared is 25. So now we're like 16 plus something gives us 25. So a quick way to do this, in fact, I'm going to ask you, what can we do? How can I work out what sum can we do to work out what's missing? What goes in there? How can I work out if I want to work out what's added to 16 to make 25? What quick sum could we do?
Do
Oh,
25 take away 16.
Yes, well done. So do a takeaway. So whereas before, and I think that people starting to type, whereas before we added the two numbers to get the final one, we just do a takeaway. So we're going to do 25 take away 16 gives us 9. Thank you, Nicole. So then we've got, we don't forget, we want to get it back to, so B is equal to 9. B is equal to 9. Don't forget we need to get it back to the squared number originally. So same as before, you need to square root it.
3.
So B is equal to 3. Yes. Okay, so, oops. Get rid of that. So the only difference before we added them and this time now we're going to take them away. So let's do another. I completely lost my train of thought when I was doing that then because a squared plus b squared equals to c squared. So then literally substitute in. So we've got 15 is over here. A and B can be any. So A is 9 plus something equals 15. 9 squared is, oh gosh, 81 plus something is 15 squared. Don't know what 15 squared is off the top of my head. There's 225. And then instead of adding the two numbers, we do a takeaway. So 225, take away 81. Oh, thank you. And then final little thing, what you always must do, 100 square root of 144 is 12. You almost sound bored, Nicole, of these. They're just so easy. Like, oh. Okay, well done, Luke. Thanks, Luke, to get off. Okay, so those ones are quite easy. Same as before. Instead of adding them, just taking them away. So I'll open up the thing so that you can practice those. So 2 more slides there. I'll very quickly get the answers so that I can put the answers up, and then you can mark them when you've done them, and then we will have time to do. We've still got half an hour, so we'll have time to do mean and range. Okay, so 5 minutes or so to have a go at those, and then we'll do mean and range. Right, okay. So lots of people have done those and finished those. Thanks, Nicole. Oh, right, I'm going to go through the answers, Ty, so you can see how I work them out. But literally, like what Nicole's just said, both the numbers on the triangle, you square them first, and then you add the two numbers together, and then you square root what's left. So you square both of these, so 4 times 4 is 16. Square this one, 7 times 7 is 49. Add the two together. Is 65. And then you have to do the square root at the end. So that is something that lots of people have been forgetting. So I've just sent a few messages to people. Don't forget to square root it at the end. So 65 is equal to 8.06. So times both the numbers, add them together, and then square root it at the end. Yeah. So let me just check question 1. Hang on. Harry. No, spot on, Harry. Question 1. So that question 1's fine. Question 2, let's do question 2. So the answer for question 2, lots of people, Harry, you've got that question 2 spot on as well. So the answer for this one, when you've times the 2, it was 80. And lots of people have left their answer like that. So just don't forget that you need to square root it at the end. So square root of 80 is 8.9. You could do 8.94. Neither of those will be fine. So that's good. Lots of people like Harry, Nicole, Jack, Grace, Darcy, James, Luke, Kate, like loads of people, Karen, loads of people got them. And Alia, you've just been putting it squared at the end. Don't forget that you need to square root it to get it back to a squared number. So it's actually 8.94 would be squared. So it's the square root of that number that you need to get back to the squared number. Question 3. This one. Loads of people got this one right as well, and Harry, you have as well. So all these you seem to have got the hang of okay. So square both of these. This was a bit more difficult because they're decimals, so it just took a little bit more working out. 8.5 squared, 7.5 squared give us a total of 128.5, which is obviously a bit tricky. Square root that, but just writing down what you get in the box, 11.34. The chances are, if it's a square root, if it's a Pythag question on a calc paper, it will be like this, where you need to use decimals. And then slide 8 is an exam question, typical exam question, and the length of that is 12 centimetres. So square 7.2. So I think this one's 51.84. A few people got this one wrong. 92.16. Add them together gives you 144, which is square root of that is 12. So James, you've got that one, and Stephen and Grace, you've got that one a little bit wrong. So I think the problem there is probably you've just done the times in wrong. You've just probably done these, when you've squared these, you've probably squared them incorrectly, I suspect. And then the next ones, finding a short side. Oh yeah, that's probably it then. You've worked out a short side rather than you've done a short side instead of the long side. And then these ones, it was just a takeaway. So I just want to sort of quickly give you the answers because I want to move on to the next bit. I think loads of people got these right, like everybody got this. So 12.7 was that one. Everyone who did it got that one. Oh, meters, not centimeters. Variation of what I'm putting on is fine. So if you've got like it not quite rounded or you've rounded it differently, then don't worry about it. 4.9 for this one, or 4.89 or 4.8989, whichever. And then this last one. I mean, everyone's got these right. Everyone who's done them has got them right. 5.7 centimeters. Let's check the units a bit better, don't I? Or 5.65 rounds to 5.7. Obviously, as long as you're rounding correctly. Obviously, the question in the exam would say 1 decimal place or 2 decimal places, so you'd know how to round it better, wouldn't you? And then the exam question was find the value of x as a decimal. And I've got here, everyone's done that as well, 7.4. Yay, so well done. Everybody's got those second set right, so that's really good. So well done. Right, okay, so moving on, I want to just go through the mean and range questions. I'm conscious of the time because I don't want to go over 2 hours because we'll be like on our knees, won't we? And a 2-hour lesson is long. So quick recap. So what I've got for the mean and range was actually a little bit of reverse mean and range mostly. So yeah, that's fine. Obviously, this is just a drop in for your own, what you use it to how you suits you. So yeah, if you need to go, James, that's absolutely fine. So the mean and range, the thing that I want to go through, obviously we do need to, you might need to just calculate mean and range straightforward, and that's important. So tell me, thanks James. So tell me in the chat, how do we do the mean and how do we do the range? So see if you can tell me in the chat how to calculate those two. How to do mean, how to do the range? Does anyone remember?
Don't you add them all up and divide by how many there are?
Yes, you do. Well done. So Stevens, give me the range. Big number, take away the small number. Good. So my handwriting is getting worse and worse on this. Highest, take away the lowest. Well done. Good. And then Karen and Nicole, total items divided by the number of items. Brilliant. Well done. So that's really written nicely, Karen. Well done. So total number. So to get to the total, add them all up. So let's put that first. Add all the numbers up. And then divide by how many? Now, I think most of you probably can do those. You add the numbers up and divide by how many there are for the mean, and you do the biggest take away the smallest for the range. So what we're going to cover is just a few little things that are slightly off from that, and it might just throw you. So calculate the mean, the temperature recorded over 5 days. What is the mean temperature? So to add all these up, if you look, there's a little negative value in there just to throw a spanner in the works. So 2 plus 3 is 5, plus another 3 is 8, plus 6 is, oh, I don't think I've done these very well. 2 plus 3 is 5, 6, 7, 8, plus 6 is 14, and then we've got minus 3, so 14 take away 3, is 11. So the total is 11 degrees, which is not what I anticipated it being. You can't see my screen. Oh. Can anyone else see? I'm sharing. I'll try and unshare and share again. See if that helps. Is that better, Karen? Can you see that now? Is anyone else struggling to see it? I've got it on my other screen. Oh, there we go. Good. Perfect. Okay, so that was easy. So 11 degrees is the total. Divide it by 1, 2, 3, 4, 5 numbers, which is going to be a horrendous decimal because I anticipated it being 10 and worked it out wrong. So 11 divided by 5 gives, oh, it's all right. It's not too bad. Gives us 2.2 degrees, which is not what I expected it to be. Now, the range in temperature, this is a bit tricky when you've got negative numbers. So the range is the difference between the biggest and the smallest. So we've got the highest value is 6. And as some of you said, I can't remember who put it nicely, the biggest number take away the smallest number. So the biggest number is 6. The smallest number, we're taking away the smallest number, which is -3. So you've got 6 take away -3, they make plus. So the difference between the two numbers, you've got 6 degrees and you're going all the way down to 3 degrees.
3.
The difference, no, it's not. It's not 3. It's 9 degrees.
Oh.
Because you're going from 6 all the way down to 0, past 0, down to -3. So the difference between them two temperatures is actually 9 degrees difference. So we've got 6, take away minus, -3. The minus and the minus make a plus and it gives us 9 degrees. So just take care with that when you're doing a range with the negative numbers included, okay? So it's the difference between from the one to the other, okay? So there's one of those for you to practice in a minute. And then the thing that I want to actually do, which I think most of you might need to practice, is reverse mean. So the mean of the 4 numbers is 10. Now, some of you, if you have Sam as your teacher, he may have been doing this with you because I know that he's a lover of reverse mean. I haven't done it with any of my groups, so and whether other teachers have been doing it or not is beyond what I know, but we basically need to do it backwards. So you need to think the mean is equal to the total divided by how many? So if we're going to do it backwards, what do we think we do to that divide? What happens when we do a sum backwards? If normally we divide by how many, what do you think we're going to have to do if we're going backwards?
Times.
Yes, times. Well done. And Karen, times. And Darcy's typing as well, which I think you'll probably put in times. So we need to multiply, okay? So the mean of the 4 numbers is 10. So we know that the average is 10. 3 of the numbers is 9, 11 and 7. So we can work out that the how many numbers, we know that there's 4 numbers, don't we? So that means how many is 4. So to be able to get to the total, we're going to have to times. So we're going to do 4 times 10 is 40. So we know that the 4th number, that the total of the numbers needs to come to 40. So we've done times the 2 numbers, and that is 40. So that works, doesn't it? 4 divided by 40 is 10. So if we know that the total comes to 40, we can then work out what the final number is. So we've got here 9 plus 11 plus 7, 27. So these numbers come to 27. We want the numbers to come to 40. So what else is missing? How can we work out what's going to be the extra number? What's the last number going to be? If it's got to be a total of 40 and we've got 27, it's going to be 13. Thank you, Karen. Yeah. So that's a little bit tricky. Did I put 2 of them in? Yeah. So let's do one more. So we've got the mean divided by the total. So we're going to go backwards. The mean total divided by how many? So we've got the scored an average of 4 goals over 5 matches. So the mean is 4, the average is 4. How many is 5? So it's 5 matches. So 5 times by something gives us, oh, sorry, what am I saying? 4 divided by something gives us 5. So it's 20, not times. So times these 2 numbers to get the total. So we've got, so we know now 4 is 20 divided by 5. So we know the total numbers needs to come to 20. So then we can add up the numbers here. So we've got 1 plus 5 plus 8 plus 0 is 14. So that means if the total's got to come to 20, the last number is in fact 6, which you guys have all worked out before me. Well done. No, Jack, not right now. Right, okay, so questions that I want you to have a go at. There's just a couple as well. So we've got a reverse mean. So on your questions, you've got a normal question there that you need to work out, mean and range, straightforward mean and range question, a reverse range question, a reverse mean, sorry, and then there's a couple of range problems which might also come up, and I haven't done any practice ones of them, so you can just see if you can figure them out, and we'll go through them in a few minutes, okay? Fine. Right, I'm just opening up Desma. Sorry, let me stop the pace. Right, so what you want is slide 5. So I'll do the pacing so people don't get confused. Slide 5 and slide 6 on Desmas. So you've got a normal mean and range, couple of reverse mean, and a range a range problem. So if you feel like confused by these, don't worry too much. The reverse mean is a bit tricky and something that we haven't really done much before. But even if you can just practice doing the mean and range straightforward, that's better than nothing. So see how you get on with those questions. Slide 5. Some of you may have noticed that on slide 6, it actually says 8 men were asked their shoe sizes and then gives 10 numbers. So that is divide by 10, not 8. But if you've done it divide by 8, that's fine because it does say by 8, but there are actually 10 figures, so it doesn't make a lot of sense, that question. Sorry. Okay, so it is 2 o'clock, so I think lots of people have probably had enough. If you want me to give you, I'm not going to go through the answers to those questions because I think 2 hours is really long enough online. If you have answered them and you want to know, I mean, I can tell you the answers very quickly if you've done some of them. So I know some people have. The mean temperature is 4. The range in temperature is 18. So again, Nicole, that's the same as before. It goes from -3 all the way up to 15. So it's 15 take away -3, which these two make a plus. So it's actually 18. Like we just discussed, this is actually 10 men, so it doesn't really make a lot of sense, but it's 12. The mean size is 12, and the range in the shoe size, the smallest shoe size on there is 6, and the biggest, I don't even, what? It doesn't even make sense, this question. They don't have size 18 shoes, can you? That's ridiculous. I got this off like Corbett or something as well. I think that's obviously wrong. But 18 take away 6 is 12. No, 14. Doesn't make any sense, that question, does it? It's really silly. Oh, is that the biggest? And the small? Oh no, 25. Look what I've just done, missed 25. So it's actually 19. And then those reverse mean ones, lots of people haven't really done them. So if you want to know what the answers were, just send me a quick message and I'll let you know. But otherwise, I think lots of people stopped at that point. So those reverse mean ones are tricky. Kate and Nicole, if you want me to go through those answers, just let me know and I'll go through them with you separately. OK, because they are a bit tricky. Right, I'm going to leave it there. So well done for working so hard. And for those of you that have stayed for the full 2 hours. Well done, because it's a long lesson. And good luck in your paper 2 if I don't see you before. And yeah, well done and bye. I'm going to stop recording now as well.